the exponent rule, which is where you bring the exponent out in front. And the second is if you have the log base b of b, that always equals 1.
So both the b's have to be the same for t to equal 1.
Yes.
Okay.
Okay, so let's try it. Let me just I want to throw out a different problem to kind of illustrate this, but it's related. So did you get this down, or do you want me?
Yeah, I got it.
Okay, so let me give you a different problem. Let's say it's log base 2 of 16. Okay, now in addition to the exponent rules, the power rules, you also probably need to know your exponent table. So let me just send you another link to a reference sheet. And this reference sheet's really good for just knowing what 16 could be. So 16 could be 4 squared. Okay, that's totally possible. It could also be 2 to the power of 4. Okay, and you have to decide which one is it. Is it log base 2 of 4 squared, or is it log base 2 of 2 to the power of 4? Well, the better choice is the one where the bases match. And if you want some explanation on that, I'll have to go a little deeper, but on this, but that is generally a preference here. So this number comes out in front. 4 times log base 2 of 2. Log base 2 of 2 is 1. 4 times 1 is still 4.
Is that always the rule?
The exponent always comes out in front, yes.
Okay. So what happens if you have a problem where both the numbers don't match?
Yeah,
Like,
so that's kind of where we're going here is let's say it's like log base 3 of 5. I'm sorry, log base 3 of 5 squared. Okay, or 25. Let me make it 25. That's probably a better way to start. Okay, so if it's log base 3 of 25, you can say, okay, well, this is really log base 3 of 5 squared. That 2 can come out in front. So it's 2 times log base 3 of 5. And then you're done. There's no more action to be taken.
so you just can't simplify it anymore?
You can't simplify it anymore.
Okay.
So let's look at number 7 next on this page, and then we'll talk about some of the other problems that are a little bit more difficult, but 7 is a more straightforward one. So you'll get something like this in a test or quiz. You'll get several of these. It'll say no calculator. Log base 15 of 225. So you have to write 225 as some sort of a base to an exponent. And this is where it's really helpful to know some of these squares, square roots, and powers. But we already said this one earlier. 225 is really 15 squared.
Okay.
So this becomes log base 15 of 15 squared. So that 2 comes out in front. So that's 2 times log base 15 of 15. What does this simplify to? What is this part?
Would be 2 times 1.
1. Yeah, because log
Yeah.
base b of b equals 1.
Yeah.
Right. So here's a kind of a, I'll just throw this question at you. Can work on it together if we need, but what is log base b of b cubed plus log base a of a to the minus 2? Any idea how to start a problem like this?
Wouldn't it just be 1 to the power of 3 plus 1 power negative 2?
Well, you bring the 3 down, right? So it's
Yeah.
3 times log base b of b plus, and then you bring the minus 2 down, minus 2 times log base a of a. What is log base b of b?
Just 1.
1. 3 times 1. And then what is log base a of a?
1.
1. So it's 3 plus negative 2 is 1. Okay, great. Let's go do a slightly more difficult problem that you will see on a test or quiz here. So I'm going to go grab number 5. Okay. Right. So this is one of those where you have to remember some of your exponent rules, which are different than the logarithmic rules. Okay. For example, 1 over 81, you can rewrite as 1 over 9 squared. Is that okay? Is that clear?
Yeah.
Okay. Now this also equals 9 to the power of negative 2. And this is an exponent rule. 1 over x to the n equals x to the minus n. And the rule is essentially that if you bring the exponent up, it becomes negative. Usually this is shown slightly differently, but this is what we have to work with today. So 1 over 81 is really this 9 to the minus 2. Now, why did I choose a base of 9 over here?
Because the log.
Yeah,
Yeah.
because truthfully, 81 is 3 to the power of 4, which becomes 3 to the power of negative 4. But that one doesn't work because the bases are not the same. You want the bases to be the same. So that's log base 9 of 9 to the power of minus 2. So now, what do you do? What can you do with that minus 2?
Move it in front of the log.
Move it in front. Minus 2 times log base 9 of 9. Log base 9 of 9 is 1. Negative 2 times 1 is negative 2. So let me give you one to think about here to try. Let's say I wanted log base 2 of 1 over 32. You want to give that a try, please?
Let me look at the sheet real quick. Would it be 2 to the power of 5?
32 is definitely 2 to the power of 5. Okay. So 1 over 32 is 1 over 2 to the power of 5. And then how do you bring that? How do you bring the 2 up? What does the exponent become when you bring it up?
It'd be 2 to the negative 5th power.
Yes. And that's what you're replacing inside parentheses.
It'd be -5, right?
Yes, the answer is -5. Any questions on that?
Oh, I get it.
Okay,
Pretty
so
straightforward.
we can, I want to make a comment about number 3 and then move on here to something else, unless you want to see, you'll have to send some other stuff for us to look at. I'm not sure how far you're in the course. So this one says the log base 17 of -289. So the log base b of x has to be greater than 0. Okay, so the number inside parentheses, this has to be positive. Okay, so this right here is undefined or does not exist. And there's a lot of exceptions in math. This is just yet another that you're going to have to sort of work through, think about.
So it literally wouldn't have an answer.
Yeah, there's nothing you can do here. It's odd that it's
So,
on this worksheet, but it's
well, what he wanted us to do is he wanted us to simplify them. So he wanted us to go from log form to exponential form too.
okay. This one we cannot evaluate. Like it says evaluate each expression. This one you cannot do. Moving between log and exponential form, we'd have to get some different problems up, which I can make up. But this one there is no simplification for. It's I guess a trick question if you like that. Okay, so let's talk about moving between logarithmic and exponential form. And let's look at one that we've already done. Let's say it's log base 2 of 32. This actually equals 5. Okay, and if you're wondering why it equals 5, 32 is really 2 to the 5th. So the 5 comes down and it cancels, but we can convert this to exponential form. All right, so I'm going to give you the answer, and then we're going to talk about how you get the answer if you want. So what most students just want to remember is like a sample problem. They want to know like where the things map. Like the 2 becomes the 2 in the base, the 5 becomes the exponent, and the 32 is the number on the other side of the equation. But these actually also go backwards. Like I can give you an exponential form and go backwards to a log form. And we can do that as well. But let's just do a couple of these going from log to exponential form. So the more generally what you're going to get though is something like this, like won't be numbers. It'll be like log base b of x equals n. And you'll have to know that this is b to the n equals x.
Okay.
So like this is probably the thing you would see in a textbook as far as like going between them, maybe with different letters.
Is it always that straightforward?
Yes.
Okay.
So let's try it. Let's try a few here. Let's say it's log base 3 of y equals 6. I want you to write this in exponential form.
Do you want me to solve the 3 to the power 6?
Nope. Nope. So that's why I chose this example. You do not want to simplify.
So it'd be 3 to the power 6 equals x.
Equals
Or
y.
y, yeah.
Yes. Yeah. And that's it. Now you could reduce 3 to the 6th, but that's it for that. Okay, so the more challenging is to go the other direction for whatever reason. I mean, it's just going backwards. Okay, but some reason that's harder. You know, I don't there's no like teaching. You just have to know, you know, where the stuff goes, that the base over here becomes the base there. The number on the side of the equal sign is the thing you're taking the log of, and then the exponent becomes the number on the other side of the equation. And I think one of the reasons it gets confusing is they'll often like switch the order, but I won't do that for the first one. Like we know from that sheet there that 16 squared equals 256. So my question to you is it's the log, and what is the base when we switch these?
16.
Base
log,
16
yeah, base 16,
of,
and then hold up. I just had a complete brain fart right now.
yeah, I mean that's the problem here is you have to be able to remember where they go.
Yeah.
And I don't have I don't have a real good like meme or something to like video. You just gotta see where they are. And it's okay, like I said, if on an exam you write, okay, actually you would, it's okay if like on an exam you're like, all right, log base 3 of 81 equals 4. So this means that it's 3 to the 4th equals 81. And then you figure out you know, where everything goes. Like if you have a like an sample problem to help you guide you, it's totally okay. All right, do you have this example down?
Yeah.
Okay, so let's do another one here. Let's say it's 5 to the 1/2 power equals p. It's the log base what in this problem?
So it'd be log base 5
Okay, of,
p equals 1/2.
perfect. Now you will be solving, but you're not solving yet. We're just doing this. We're just like
Yeah.
rewriting. It's like going back and forth between forms. Okay. All right. Now we've not talked at all about E or ln, so we should do that now. Oh, actually, one more thing. If I write log of 1000, what is the base when no base is written? Did you cover that in class?
No.
So if no base is written, this is really log base 10. Now, how do you
So
simplify this? Yeah, go ahead.
whenever there's no base, you just assume it's a 10.
Yes. with
Okay.
log, yes. And you'll see problems where it's not written. So I want to go through a couple of these, then we'll go to ln and e.
Should equal 10, right?
So this is log base 10, and 1,000 is 10 to the power of 3.
Oh, yeah.
So what would this equal?
Should be
Log base 10 of 10
be-
reduces to
10 to the power of.
Oh, no. We're just simplifying. I'm sorry.
Oh, okay.
I'm sorry. Now I understand why you gave me that answer. No. I want to just go through simplifying logs right now. So we'll say simplify, and then it'll be clear.
Yeah, that would equal 1.
Yeah,
Or that would equal 3.
good. Now here's another one you might see. Log of 0.0001, excuse me. And no calculator. So you have to remember how to write that as a fraction or as a power of 10 or both. Let me know if you need help with that.
So I'd find what power the 0.0001 would be to equal 10.
Yeah, and like if I'm helping you a little bit here, I'm going to remind you that 0.1 is 1 over 10, which is 10 to the minus 1. 0.01 is 1 over 100, which is 10 to the minus 2. And this is only if you just haven't done it in a while. And you'll remember you probably do more of this in like if you've taken chemistry or physics class, you would do a little more of this. But every time you move the decimal once, twice, 3 times, 4 times, you get a minus 4 there. So what would this equal? What's the log of 10 to the minus 4?
It equals 4, right?
That negative 4 comes out in front. Negative 4 times log of 10. It's log base 10 of 10.
Oh, it'd be negative 4.
Yeah, negative 4.
I thought the 4 became positive.
So only if it's on the bottom, right? Like it's 1 over 10 to the 4th, but then when you bring it up, it becomes negative 10 to the minus 4. The exponent becomes negative. Okay, let's talk about this one. So sometime in the last 100 years, I'll say log base e of a number became really popular. And instead of writing it as log base e, ln is what has been now used for a while. So ln is really log base e, okay? So again, like what some teachers will sometimes do is they'll give you a problem where like, what's log base e of something? And they'll maybe even make it a calculator problem. And you have to know, like I'll put 5 here. And you're like, oh, that's natural log of 5. And you go to your calculator and you get a number. But most of the time you're going to see problems where it's ln. All right, so this is maybe something to keep in mind. It's not super important. What is important is that the natural log of e equals 1. This is something you have to remember. And you're like, well, how is that 1, Matthew? Like, that looks weird. Well, I'm going to use the property we just said. ln is really log base e of e. The exponent of e is 1. You bring the 1 out in front, so it's 1 times log base e of e. Log base e of e is 1. 1 times 1 is 1. So this thing on the left here, you have to remember.
Got that.
So let's say I gave you a problem like this. What's the natural log of e to the fifth? Can you tell me what that is?
Would it be just 5?
It is 5. My screen is okay. So you're like, oh, that's not too hard. Well, let me give you a more difficult one. Let's say it's the square root of e, natural log of the square root of e. So what I'm really asking you in this problem is the square root is what in terms of an exponent? Like if you recall, square root of x equals x to what power? What's the exponent?
-2
1
or
half.
1/2. Yeah.
1 half. So this is really natural log of e to the 1 half power. And now it's a lot like the last one. So that just equals 1 half. So this on the right is, again, maybe an example of something you want to remember. So let's say it's natural log of 1 over the square root of e. Can you tell me what that would equal?
Would that fraction be 1/4?
The square root of e?
Yeah.
So so you're just using the previous stuff that we've been using here. So it's 1 over e to the 1 half power. To bring the e to the 1 half up, what happens to the exponent? Like let's go back and look here at the previous problem with the tens. What happened to the 10 to the fourth? What did it go to?
Oh, it became negative, or 10 to
Yeah.
the -4.
Yeah, 10 to the -4. So this becomes e to the negative 1 half. So now how do you simplify this?
So
So just like in the previous problems, you can bring that exponent out in front. Negative 1 half times the natural log of e. The natural
it
log
just
of e
equaled
is,
-1/2.
yes. Okay, so let's try some synthesis here. Let's go with log base 3 of 9 minus the natural log of e squared. Okay, so I want you to simplify this.
Would it equal 0?
Yes, this is 2 minus 2, which equals 0. Okay, so let's try a little bit harder one here. Let's go log base 5, 1 over 25 minus the natural log of e to the -3.
Would it be -5? Or
So tell me, what did you get for this first one? What does it reduce to?
-2.
This one's -2 for sure. You bring that negative out in front, right? So it's -3 natural log of e. Right, so two negatives make
Oh, positive would be
positive. Yes,
1.
it's -2 plus 3, it's just 1. Okay, let's try another one here. Let's go natural log of the square root of e minus log base 2 of 1/4.
Would it be -2.5?
Okay, so you say negative 2.5. What is the natural log of e? Square root of e, sorry. What did you get over here on the left?
1/2.
1/2. Okay. Now the one on the right here, I'm going to just do a little bit of writing here. It becomes 1/2 squared, and then it becomes 2 to the -2 power. So that -2 comes out in front. So you get 1/2 minus a -2 log base 2 of 2. So those become +2, and this is log base 2 of 2 is 1. So it's 1/2 plus 2. And I get positive 5/2 or 2.5 for this one. All right, let's try one more here. Natural log 1/e cubed plus log base 9 of 81. See if, yeah, we'll try this one here.
How would you get rid of the 1 above the e again?
So the rule is 1/x to the n equals x to the -n. And in words, you take the thing that's on the bottom, you bring it up top, but you negate the exponent. So an example would be like 1/5 squared becomes 5 to the -2. Does
So in
that
this
help?
case, it become e to the -3.
Yes.
So it'd be -1.
Yes. Sounds right. So this is -3. This ends up being 2, -1. Okay. So one more here, and then we'll move back to going between forms. Let's say it's a log of, I don't know, 0.1 plus log base e of e to the 0.3 power minus log base 2 of the square root of 2. Give this a try, please.
So the first one would be -1, right?
Yep, I agree.
What do you do if the exponent is a decimal?
The same thing you do if it's a whole number. You bring it out in front.
Oh.
You always bring the exponent out in front. That's the whole point of this, what we've been doing today. So it just becomes 0.3. And then this one on the right, you can write the square root of 2 as 2 to the 1/2 power.
And put 1/2 in front.
Yeah,
And then that also becomes 1/2.
that's right. And then you can combine decimals and whole numbers.
So it'd be -1.2.
Yes. All right, good. So in the time we have left, let's look at we've done it. We did a couple of these problems where we said like log base 2 of 32 equals 5, and then we wrote it in exponent form. We said like 2 to the 5th equals 32. So you can do the same thing for natural log. Like let's say it's natural log of e cubed. Actually, let me not do one with an exponent. Natural log of e equals 1. Okay. The way this works is just like over here. Actually, this is a bad example. Let me not do this one. Let me just use letters for this one. Let's say the natural log of x equals y. And this one is a little bit different. It becomes e to the y equals x. And you're like, well, wait, where's my base of e, right? Well, it's there. It's log base e of x equals y. It's just not written that way. And so it becomes e to the y equals x for the same reason as the first line. So I think the hard thing for you as a student is to remember when it's ln, you're going to use e as your base.
Okay, got that.
So let's try an example here. Let's say it's the natural log of x equals 3. What's the equivalent exponent form?
So it'd be e to the power of 3 equals x.
That's right. So now it could be a little bit more, exotic. It could be like the natural log of p squared equals f. So e to the f equals p squared. So this thing inside parentheses could be like more complicated than just a single letter or a single number. So let's summarize our rules here in the last few moments here, and let's do log base b rules, and then we'll have ln rules over here. So the most basic one for each is log base b of b. This equals 1. We did that a bunch today. The equivalent rule is natural log of e equals 1. All right, the next rule we talked about is log base b of b to the x equals x. You bring that x out in front. The natural log of e to the x also equals just x for the same reason. And then we did a few of these rewrites. So log base b of x equals y. I'm probably misusing my letters here, but this became b to the y equals x. And then if we have natural log of x equals y, this becomes e to the y equals x. And that kind of summarizes everything we did today with formulas. So Jadon, that is it for us for today. I thank you for scheduling. Sorry again about the link, but that's been resolved, and I'll send you the notes here shortly and be happy to help you again here coming up, whenever that is.
Thank you so much.
You're welcome. Hope this helped. Have a great day.
It did. See ya.
Okay. All right. Talk to you later. Bye now.
Bye.